Today we are asked to simplify this fraction. Root 2 minus 1, all raised to the 1 minus root 3 power, all divided by root 2 plus 1, all raised to the 1 plus root 3 power. So, where to begin in simplifying such a fraction? How do we even start? Well, first let's just review some basic rules of exponents. So take a number, a, and we know that if we raise it to the nth power, and then multiply that by that same base, but raised to a different power, m, we know that that's going to equal, the product's going to equal a to the n plus m, raised to the n plus n power. And then we also know that if we have a to the n times a different base this time, b to the same n power, that will equal ab raised to the nth power. So with these basic exponent rules that we can remember, how can we use them for this fraction? Well, what do we want to simplify? How do we begin with this fraction? Well, I want us first to get rid of some radicals. There's a lot of radicals in here, and the one that I want to start with is, how about just this root 2 right there? Because first of all, I just want to start simplifying the denominator before I do anything with the numerator, and many times radicals in exponents tend to sort themselves out once you've worked with the base. So let's just try to simplify this root 2. How do we get rid of this root 2? Well, one way is to use the conjugate of this expression, and so that's just root 2 minus 1, right? So if you multiply this fraction by, well, if the denominator here is root 2 minus 1, then the root 2 can be cancelled. And if we raise this root 2 minus 1 actually to the power of 1 plus root 3, that same power, then both of these bases can be put together, right underneath that exponent. So I think this seems promising. So let's just multiply, let's just have the numerator be the same thing, and then simplify. So let's start with the denominator. So the root 2 plus 1 and the root 2 minus 1, they will go together, all raised to the power of 1 plus root 3. We'll work with that later. And then we have, for the numerator, we have root 2 minus 1 times root 2 minus 1, but they're raised to different powers. So since they have the same base this time, we can actually add the powers here. So what's 1 minus root 3 plus 1 plus root 3? Well, that's just 2, because the root 3's cancel out. Well, so that's root 2 minus 1 raised to the power of 2. It's getting simpler. So now we can simplify yet again. So let's just expand the numerator really quickly. So root 2 squared is 2 minus 2 root 2 plus 1 negative 1 squared, which is just 1. And then the denominator. Well, if you look here, if we have a number times its conjugate, we can have that special effect with the difference of squares, I guess. So if you have root 2 squared, that's just 2, minus 1 squared, which is just 1, and then all raised to the power of 1 plus root 3. And since 2 minus 1 is just 1, and 1 raised to the power of anything is still just 1, then this denominator is just 1 then, it seems. So this division effect is just effectively cancelled out. So now all we have to do is just work with the numerator. And that's pretty simple, I would say. So 2 plus 1, that's 3, minus 2 root 2, quick maths, and we are done.